Hi, and welcome to my Simhangar. One of the most fascinating things in sim building to me is that feeling of using physical switches and displays. It's a completely different immersion compared to clicking with the mouse or using a keyboard. But to get this feeling, an interface between the switches and the computer is necessary. In version 1 of my simulator, I used Beta Innovation's Gamma Ray 256 to interface my panels to the computer. It worked really well, but wasn't seen as an HID device in Windows, and it needed a separate software to map inputs to keystrokes. And as you can see, wiring was, let's call it, complex. Since then, a lot of time has passed, and there are so many easy to use microcontrollers out there that I decided to go with a complete DIY input-output solution I call IOC, Input-Output Controller. For outputs, I'm using multiple Arduinos like Mega and Nano, but the heart of the whole input system are Arduino ProMicros, since those can be seen by Windows as dedicated joysticks. I mounted the Arduino needed for the write console directly inside the KY58 panel to make maintenance easier, since the right side of my sim is close to a wall and I won't be able to access it from the outside once it's assembled. All the other panels of the write console connect to the KY58. Only anti-ice and the oxygen regulator have dedicated connectors on the KY58, since those directly use pins on the Arduino. All others are connected through their own bus I2C. The Arduino ProMicro doesn't have enough input-output pins, so I'm using 4 MCP2307 I/O extenders, each adding 16 pins to the system. Those chips sit on the avionics power panel, the KY58 panel itself, the air condition and the HUD panel. All the switches of those panels are then connected to the pins of their I/O extender. Communication between the main microcontroller and all the MCP2307 is done through the I2C protocol. I2C needs just 2 input pins on the microcontroller, and this made wiring a lot easier, and the code to read the inputs of the I/O extenders is not much different than reading regular Arduino pins. Since the air condition panel uses only 4 of the 16 pins on its 2307, the leftover inputs are used for the other panels at the front of the console: sensor, power, nuclear and serialize panel. These 3 only connect to the air condition panel and won't work on their own. The firmware of the system is completely written by myself, which makes any changes, if needed, very easy. It's only about 600 lines of code, so not too complex, but it does its job. The joystick library does most of the magic. It makes the Arduino look like a joystick to the operating system. All buttons and axes are just created within the code, and you can set axis values or button presses and releases without even needing to have real hardware connected to it. So the main routine just checks all hardware inputs and then sets the corresponding joystick buttons. To make this mapping between hardware and software buttons a bit easier, I created a little data structure that gives each input pin a clear definition of what type of switch is connected to it, toggle or rotary switch, what joystick button number should be activated, and in case of a toggle switch, what joystick button should be activated when the input gets disconnected. This way I only needed to connect 1 pin for 2-way switches or 2 for 3-way switches. I also implemented a few features I thought would be a nice gimmick or may come in handy in the future. But the main purpose is, of course, interfacing the switches to the computer. The Arduino shows itself to Windows as F-16 Archons IOC, so I can easily distinguish between all the controllers that will be connected in the future. This takes a bit of work and configuration of the boards.txt file inside the Arduino IDE, but it looks just better than 3 or 4 joysticks all called Arduino ProMicro. In regular configuration, which I call continuous mode, a specific joystick button is held as long as the corresponding switch position. As you can see, each switch change creates the corresponding joystick button change. Sadly, the Windows control panel only shows 32 buttons, but Windows supports up to 128 buttons per device, and luckily that's also no problem in Falcom BMS. Configuring the inputs in Falcom BMS is quite easy. Open the key mapping section of the launcher, select the command to map to, activate the switch, and click Save. Once everything is set up, it should work like this. It's really satisfying seeing the switches in the virtual cockpit move with the physical ones. One little Easter egg I implemented is the oxygen regulator. It's more or less not supported in any sim right now, so this way all inputs can be mapped freely in the sim for any purpose I like. Since there also is no data for the pressure gauge, I decided to move the needle according to the oxygen percent switch. In the real panel it's an on-off switch, but I got my research wrong and used the potentiometer as analog input, and to be honest, I really like it that way. The test mass position of the third switch is only momentary, so I used it to enter the configuration mode of the controller. If held for 2 seconds, config mode is enabled, and to have a visual indication of it, the needle moves to 100%. I thought it might be fitting that the mode switch on the KY58 panel will get the purpose it deserves. The P position puts the controller into pulse mode, where every joystick button is not held, but just gets pulsed when the switch position is changed. This could be necessary for older sims that don't work with held joystick buttons. The C position puts it back into continuous mode, and the behavior is the one we've seen already. At the moment there's nothing more implemented in configuration mode, but maybe you'll have some ideas what it could be used for. And that's it. That's how you build yourself a DIY input-output controller. All the files for the Archons IOC are available on my GitHub. Link is in the description. Thanks for watching.